Did you get a microphone? You got a mic?
Yeah, I'm here.
Are we started? You're ready? Oh my God. Hello. I didn't see you there. How are we doing, friends? Thank you very much for spending time with us today. We have the wonderful Anthony Shaw. Big applause for Anthony. To share with us that something we think is very special. Some people have said why. Anthony says why not? Python in .NET, peanut butter and chocolate, cats and dogs living together, mass hysteria. It's wonderful, and I'm very excited because we're going to show you something that Anthony and friends have made called C snakes.
Yep.
Okay, why would you do this?
Yeah, I think you raised a good question, Scott, and I've got 25 bullet points to take you through this. Python or .NET, I think maybe is a question. And this started, we got a picture from 2017. This is the first time I met Scott. He's at PyCon, which is the Python conference, and you were giving a speech. Do you remember that?
I have no recollection of this picture.
I took this picture. That is my staff. It was 3D printed. It has a large Python logo at the top. And I was hoping that some of this would rub off on Scott, and over the next few years, he would eventually come over to the Python side, and I could get Scott away from C#. Has that happened?
Oh, you're here.
Oh, so that's true, yeah. And now I'm writing C#.
You got your peanut butter and my chocolate, and now I love Reese's Pieces.
Yeah, so yeah, the question is really why pick one or the other? Or the question is why not use both at the same time? And this isn't really a new concept. Lots of languages have got integrations between different things. Python has this. Python under the covers is written in C. Lots of Python modules now are written in Rust. NumPy, which runs a lot of the AI stuff you see out there, is actually written, a lot of it's written in Fortran. Has anyone used Fortran? Raise your hands. Nice.
I don't believe it. I don't believe it for a second.
OK, cool. Yeah.
Are those real Fortran hands? All right, Fortran. Good job, Fortran. Sorry, I didn't expect more than one person.
Yeah, so I mean, it's not really a new thing to combine different languages together. I guess the question is why you would want to do that in the first place.
Yeah, and when I say why and why not, like honestly, I think about when you're reading a book in English and then suddenly there's a French word and it feels the need to be in italics because it's fancy. And I always think about, why did they pick that word? And I realize, well, because that was the word that they wanted. That was the right language for the moment. And when you switch back and forth, we just declare that, like, oh, English, that's the language that we have. Well, there's lots of really great languages. JavaScript, that we've been inflicted upon us with this language that it's not the language we deserve, it's the language that they gave us. Why not make it easier to move between these languages and pick the language that is good for the job? And now you had said it had been done before. There'd been things. What are some examples of other attempts at getting Python and .NET to be friends?
There's two big ones. One is IronPython. I think at one point was sponsored by Microsoft or developed by Microsoft.
Yeah.
That was an idea to write a Python interpreter in .NET, which is really quite different to what I'm going to present today. And a number of benefits to doing that. Essentially, you could sort of freely change data in between .NET and Python. But the biggest downside with IronPython is that lots of Python is actually not written in Python. It's written in C. And nowadays, actually, it's written in C, C++, and Rust. And it wasn't compatible with any of that. So if you wanted to pick up something, an extension to Python that uses a lower level underlying language, all of a sudden it just doesn't work.
Yeah. Leaky abstractions leak by their definition. And if you are using something in Python, like for example, both of us happen to be using ARM-based computers.
Yep.
And you might grab a Python library and think it's great, and then it starts to want to compile some C or compile some Rust, and then you start pulling in a tool chain, and suddenly the abstraction that is great, this ARM device works amazingly, starts to leak because someone didn't think about some ARM-y thing deep into the beast. And it is simplistic to think that you should be able to take a .py file, drag it into your .NET application, and just have it just work and say, there's a function in Python, and I'll just call that function.
Yeah.
That was the attempt. That was the dream. The dream is to take a py file, drop it into your .NET app, and call it. But to do that would be impossible, effectively.
It would be pretty hard. So we've got a couple of points, actually. Why choose? So we kind of go back to why use Python. So when I presented this project, which we're going to go into, to .NET developers, they've come back and said, why would I use Python in the first place? And when I've presented this to Python developers, I just got back from PyCon, which was just last week. I presented this, and they say, why should we use C#? And the question is really, what benefits are there in either platform? And then what benefits do you get by combining them together?
Yeah. There is a deep and broad support in the enterprise for C#. A lot of people know how to do things in C#. It is demonstrably fast, and with the modern jitters and the modern garbage collector, in some instances, C# can literally be faster than unoptimized C. So we have insane perf happening on C# at speed. That's a fact. But at the same time, Python has a massive ecosystem of libraries, and it is preferred by data science people. And for us to take hundreds of thousands of really cool libraries and try to port them and make them work in .NET could be challenging.
Yeah. We had to think long and hard about this list because we didn't want to hurt anybody's feelings. And it's difficult to have these conversations with developers who love a particular platform or a particular language.
Right.
When you pitch something else, and you say why it's better, it comes across as you criticizing why the thing that they love isn't good at that.
Right. There is a long list of things, and arguments could be made that both sides are true of the other side. So we have decided in this talk to be non-denominational. So instead of going, don't eat pork, but if you do, here are some great recipes. Okay? So do what makes you happy, and we're going to show you how these two worlds can live happily together.
Yeah. So I'll advocate for Python just now, although I've been writing a lot of C# recently. It's really, really confusing to switch between the two without having a mental break. I'm putting semicolons in my Python and curly braces.
Yes. Yes.
Yeah, and I'm typing a lot of lines in my C# code.
Where the good Lord meant. That's the semicolon button. Boom, semicolon.
There's a line break. It's just easy. It's a good way to separate your code. I don't see why you need an extra character. Anyway, so Python does actually have semicolons. I know it's a tedious joke. And you can put multiple statements on a single line. It's just, you shouldn't do that. To advocate for Python just quickly, I don't know if anybody's heard, but Python is quite popular. It is currently the number one language in the world in terms of adoption, in terms of usage, in terms of repositories, pull requests. In terms of lines written, I think that's a poor metric because languages which are really verbose probably create more lines. So maybe in terms of lines written out there, maybe it's Java. But
well, I think that's an unfair thing. To count lines written means that they haven't seen LINQ in C#, where an entire application could just be a one LINQ query that just all in one line.
That's true. So things that Python is good at is really good at web applications in the back end, but so is .NET. So when we put this together, I wasn't really interested in addressing that particular use case because we've got ASP.NET already. It's great. If I'd have introduced Flask and Django and things like that to .NET developers, it would have been a bit of a shrug, like, OK, great. You can write a back end, but we can do that already. We can do one that scales really well in .NET. But when we look at data science, machine learning, and AI, those things and Python go hand in hand. And if we look, and we're going to demo a bunch of stuff today, but a lot of actually the reason that Python has been so successful over the last 10 years is there's like an ecosystem of libraries that are designed for doing specific scientific tasks. And most scientists out there who are coding to do their experiments and their research are using Python. So you've kind of got this foundation that people are learning Python in school and college, that scientists are doing their research in Python, they're visualizing their research in Python. And so we've got this momentum where more and more work on the scientific side is being done in Python. And so when we've had this massive boom with things like AI recently, which I don't know if anyone's heard about that this week, but that and Python, again, go hand in hand. So when you look at how the models are being built, how they're being trained, how the data is being prepped before it goes into the models, that is all Python. So if we ask the question, okay, great, how can we make that all .NET?
Yep.
Would that make sense?
It would not, because then we would always be chasing the taillights of Python. While on the .NET side, it's in enterprises all over. We've got strong IDE support within Visual Studio. We've got support in Visual Studio Code now. We've got JetBrains. We are cross-platform, running everywhere. The speed gains that we're seeing between .NET 6 and .NET 10 are crazy, orders of magnitude.
Yep.
We're running sites like Bing. These things are all just showing that .NET is a highly performant environment. Mm-hmm. The garbage collector gets better every year. If you've ever read Stephen Tobe's performance blog, the only blog that can actually crash a computer with the length of performance improvements. It actually can have out-of-memory errors in the browser while .NET is still running strong in the background. So .NET also has things like Blazor, things like ASP.NET, things like minimal APIs. So there's rich application support that we think rivals things like Django. But we don't want to have to pick one, especially now when we have things like .NET Aspire. Right? Having Aspire be able to bootstrap whole entire ecosystems with a single command line and have a wonderful dashboard that also now uses things like OpenTelemetry. .NET is getting along with everyone better than before. So let's squish them together, do what .NET's good at, and then if I see a Python library that I find attractive or I find a model somewhere in Hugging Face,
yep.
I wish I could use that model. I want it to just work.
Yeah. So the goal with this project is that we can take something from the Python ecosystem and drop it into a .NET application and just make that application slightly better. So that's really the goal here, is that we've got tons of things in the Python ecosystem that are not available in .NET, or they don't have the same maturity, and we can just pull some of those libraries or packages, add them to a .NET app, and then make it richer.
Wouldn't the easiest thing to do just be to run a Python app, localhost 1234, and then I'll run a .NET app, and then we'll just talk with like 2 cans and a string, and JSON. That would be cool. It should work just fine.
Okay, so we can do that today. Good question, Scott. I actually prepared for that.
How convenient.
Ahead of time. It's one of the things I did prepare for. So this is something we could do today. We've got a .NET process. We're going to go reasonably low level in this talk. What did we say it was, level 300?
I said 400, but then they made it 300.
Okay.
It's probably 600.
Okay, yeah. Well,
do people know what that means, level 300, 400? Like 400 would be like 4th year of school, and then 600 would either be graduate level or someone who's just really sticking around for senior year a long time. Depends. It took me 11 years to finish my undergraduate, so I don't know what that counts as.
I'm still trying to finish mine. So in .NET, we've got our .NET process that has threads. They're managed by .NET. You rarely actually have to care about threads in .NET. You just kind of run stuff and it just works. Or you
Is that
have
what
tasks.
you think it's like over here?
It's a lot easier than it is in Python, but we won't cover that today. You've got your assemblies, so these are things that you're installing or importing into the process. And then it's got a pool of memory. So that is owned by the process. There's a heap of memory. You create objects in .NET, and they're allocated in the heap, and .NET manages those for you.
Yep.
So if we then have a Python process, which has got our app, and we put them side by side, Python has its own way of managing threads. It's got its own way of importing modules, and it has its own way of allocating memory. So we've got 2 processes, and then if we wanted to run something in Python from .NET, we could put a HTTP REST front end on top of the Python app, and then write a HTTP client on the .NET side. So we send a request and get a response back. That's basically how most people are doing this today. And it works pretty well. Like it's, for basic text and stuff like that, it's fine.
Yep. And it could have been JSON. It could have been XML, as God intended. Right? They could have done this in SOAP. Right? SOAP would have been a perfectly cromulent way to do this.
Yep.
But I think we're paying a cost as we leave a process. We're paying a number of costs.
Yeah, so this kind of design is OK for web apps. It's OK where you're passing strings backwards and forwards. And when we get into numbers, that actually gets a bit more complicated. So JSON as a spec has 2 types of numbers. It's got integers and floats. The floats, there's no real standard as to what the precision is. If you work in AIML, you care a lot about the precision of the floats. It's not a particularly efficient way of doing it. You've basically got 2 copies of everything. And when you send a request over and you want to send data backwards and forwards between them, you've got to encode that data, send it over the network, deserialize it, and then copy it back again. So you've got this overhead between the two processes. If you're just sending a couple of messages backwards and forwards, it doesn't really matter that much. But also, when you make changes to what it is that you're calling, so you're developing the backend service, every time you add a parameter, make a change, you've got to update the API. That's why gRPC is really popular. But as a standard, like not particularly great. Also, if there's an exception or something happens in the backend, you've got to figure out, okay, how do I catch that exception? You're sending that over HTTP, which is really difficult. So as a developer, I feel like this is a lot more complicated than just writing it in .NET. I think everyone agrees probably with that. Like if you're coding something in Python, you're coding it in .NET, and you've constantly got to update this client backwards and forwards. Another issue is that if you've also got to think about the authentication. So is it just like a public HTTP endpoint? Like where is this secured? What information are we sending backwards and forwards? How are we securing it?
Things are leaving memory of one process, going across, jumping into memory of another.
Yeah.
Multiple copies, like you said. There's also another huge problem with this solution, is that I have to learn Python.
It's not that hard, Scott. They're teaching it in 3rd grade now.
Oh. That one hurt.
Yeah. So yeah, we've kind of focused on the dev loop. So, okay, I'll stop complaining about this system. This is what we have put together instead. So this is a different design. This is a project called CSnakes. It is actually, have you heard the term nerd sniping, Scott?
I know what nerd sniping is. A wonderful term. Y'all familiar with nerd sniping? Nerd sniping is when you tell a nerd that something can't be done, and then they freeze up, and they can't concentrate or talk to their families or shower until it's done.
So last year at Build, Stephen Tobe nerd sniped me and said this wasn't possible. So I'm presenting this back a year later and haven't done anything else other than this for the last year. So it's been quite effective as a nerd sniping method. CSnakes, what we're doing with CSnakes is we're actually embedding Python into the .NET process. So the Python threads are the same threads as the .NET threads. The memory, the heap memory for Python is in the same process as the .NET one. And the Python modules can be imported. So CSnakes is a .NET package that you can install and run. You can drop Python into your .NET project. And when you run it, it will embed Python into .NET. And it's compatible with anything that runs on Python today.
It's compatible with anything that runs on Python today because it's Python.
It is Python.
It's not emulating, simulating. It's not a simulacrum. It's literally Python.
Yeah.
I don't believe you.
So Python has a special skill that not many people know about in that it can actually be embedded into other programs. And then it has like a low-level API, a C API, where you can invoke it separately. That C API is pretty tricky to use. So there have been a couple of attempts in the past to just wrap the C API and make it available. That's where you get into things like segmentation faults, which you don't typically see as a .NET developer. But if you're a C developer, that's your bread and butter. So what we've done with CSnakes is we've basically wrapped Python's embedded interface and made that available as a .NET package. And then we've added a stack of tooling on top of that, so it's really easy to run Python programs in .NET.
You want to show?
All right, so we've got a cleverly named demo now.
OK, basic demo. So here is a solution called Simple Samples. We have a console app right here. We have a program.cs, and we have a aotdemo.py, 2 files sitting next to each other in the same application, same project. Over here, on the right, we have a Python function definition or method. You call them methods over in your world?
That is a function.
Is that a function? What's the difference?
Function stands alone, and a method belongs to a class. Yeah.
You teach that to 3rd graders, you say?
They teach that to 3rd graders.
So, so this here is returning a list of string?
Yeah, so this function doesn't have any parameters.
Okay.
And
makes-
that sort of arrow thing. People say that Python...
Pointing the wrong direction, that one?
Yeah.
Yeah.
So Python kind of has... Python is dynamically typed. People say it's weakly typed. It's not. It does have types. You just can't see them. Also, and actually, I'm not going to get into this. Although we do have a year, as I say, one of my colleagues, Aaron Powell, who worked on this project, is great. I say that typing in .NET is actually a lie. It doesn't really exist. It's all just memory.
Okay. I will be calling Anders and asking him about that. Okay.
And it's the same in Python. We're just a bit looser with typing. So we can say this function returns a list of strings, but you can give it, you can return a list of numbers if you feel like it.
And then it's totally fine. And then you have there's people who go like this, and there's people who go like this, and there's people who go like this, and then there's people who go like kebab casing or whatever.
Yeah, that's kebab case.
I don't know, cool thing. And then there's like edgelords that are like...
That's leet case.
Yeah. Is that leet?
The top one is Pascal case.
I feel very leet with that. And then there's whatever this is. What is with the...
That's called screaming snake, that one.
Screaming snake.
So snake case is where you use underscores. So that's snake case. And then if it's all capital letters, it's called screaming snake case.
Yeah, this is
But that's
great.
not the point of the
Great.
demo.
This is great. So here's a function in Python that we want to call.
Yeah.
Okay.
So we made a function in Python. This is the most basic demo we could think of. It takes nothing, and it gives you back a list of strings.
Cool.
So how would we do that from .NET?
All right. So over in .NET world here, this here might look like a lot, but honestly, all it is it's right here.
Yeah.
Okay. So we're going to get to that, but we want to just call out that we're using the csnakes runtime. We're pulling in some extensions, hosting, and dependency injection, and then in the world of things being on one line or not being on one line, yeah, I know, that's one line. Okay. So that line ends here. So we go and create this default builder, and if you've seen things like this before, if you've done ASP.NET, or if you've done kind of idiomatic modern C# and .NET, you go and you create these builders for this host, and we're saying with this extension method, this is where some of the magic starts happening. We're saying, hey, some of the services I might want to use this service or that service. You just say with Python.
Yeah.
That's crazy. I think that's amazing. So with Python, in this case here, is an extension method that you gave us.
Yeah.
Okay? And then you say with home. What does that mean?
This one's a funny Python thing. You don't really compile in Python. We don't have types. We don't have compilation. Well, anyway. So you don't really compile in Python. You have some files, and then you run them. So you need to tell it where the files are. Otherwise, you can't run them.
And then you have different versions.
Yep.
And what's the deal? 3.1 is bigger than 3.12, or 3.14 is bigger than...
Yeah, so 3.13 is the current version.
3.13?
3.13, 3.13. Yeah.
Okay, cool. That's the biggest one.
Yeah, that's the biggest one we have.
Okay.
We're working on some bigger ones. We realized pretty early on with this project, installing Python is quite tricky. So to make that simple, we've added another extension method called from redistributable, which will go and fetch Python for you and run it for you.
Right.
So to make things easier, and it runs on Windows, Linux, and Mac OS, so it's cross-platform. csnakes will just go and fetch a redistributable build of Python and drop it into AppData local. So AppData roaming on this one.
I did not have to do anything. I literally cloned this, and I ran it. There was an initial startup cost when it downloaded that thing. It threw it, in this case, to AppData. It could put it somewhere else, right? I could stick it in bin debug or whatever. It's not a Python installation in the sense of the system doesn't know that it's there, but the app does within the context of csnakes, which is the one that we want. So we're just like you have self-contained .NETs, where you might have an application that has its own little private. Here we've got kind of private but shared amongst the csnakes constituency.
Yeah, you don't have to use this. It's just convenient. And so if you're shipping a .NET app today, you know how to build that. You know how to distribute it. You know how to put it into Docker or to put it on your servers and stuff like that. You don't suddenly have to learn how to install and configure Python. So it just makes it easier for you.
It was a joy. Clone, run. Okay? Now we come over here and we say, get a service. I want to get a service, which is the Python environment. Now, this took me a second to understand. I asked about this at the beginning. So here I have this environment. That's the Python environment. And I said AOT demo, and then I said cool things. Now, I teased you about the underscore, but with respect, he actually converted their freakishly weird naming process to a normal human-readable naming process as a convenience. But what is AOT demo? I don't remember making a function called AOT demo.
That is the module. So in Python, you've got files. Each one of those files is called a module. And that module was called AOT demo.
Oh. Okay, so this file, AOT-demo.py, became that module, which in this case is a static method hanging off of environment.
Yeah, so environment is an interface. And then for every module that you have in Python,
or an extension, rather,
we add an extension method with the name of it. If you call that, it will basically spin up that module. And then that is essentially a static class. And that static class then has methods on it, which are the functions inside that Python file.
Should I look at that, or will I freak out?
You can have a look at it if you want, but...
You paused. I felt uncomfortable.
I mean, it's a lot of... This is a lot of C#.
A lot of underscores.
We generate this for you, so...
That makes it okay?
What do we call that? Name mangling?
Name mangling.
Yeah, we call that mangling.
Okay. Point is, I don't ever have to look at that.
You don't care. It's just done in the background. It's a source generator, which means that from Visual Studio and Visual Studio Code, or just MS Build directly, when you drop your Python file into your .NET solution, it's going to generate that class, all the interface, and all the code to convert the types backwards and forwards between Python and .NET.
Right. And to put a really fine point on it, if I open up dependencies, you can see CSnake source generation. There's a hidden file, but again, nothing's hidden anymore in the new world. It's just AOT-demo.py.cs.
Yep.
And it's there. So that's pretty cool. And then you never have to look at that. I had to go digging for it. It's invisible. Okay? So then we say, for each thing in demo cool things, you notice that you're calling a method here, but then you're enumerating over it. So that's interesting because for each goes over IEnumerables.
Yep.
And do y'all do an IEnumerable?
We do, yes, kind of. Enumerators and enumerables are two separate things.
Okay.
They are in .NET as well.
Yeah.
But a list is a sequence. So we're returning a list of strings. So we can loop over that in .NET. So it gives you back a read-only list, in this case, an I-read-only list. And we can just loop over that. And those are typed. So we're saying we give you back a list of strings. So if you hover over that method, isn't it? You call it .NET?
So I go over cool things.
This is a read-only list of strings. And you just call it, and it works.
Now, I thought that would be an I list of string. It's a read-only list.
Yeah, I made it a read-only. Actually, Aaron's decision.
You're going to just call them out in front of everybody?
Yeah, because we wanted to make it clear that it's immutable.
Okay.
We didn't want you changing the values and then wondering why Python suddenly didn't know about it.
Well, then brings us to this memory idea, right? You might intuit that an I list of strings got copied and moved over here. Am I looking at your strings in your memory, or am I getting copies of your strings?
In this case, you're getting copies because .NET string format is different to Python's. We use UTF-16 as a standard in .NET, and Python uses UTF-8, so we can't just use the same memory.
But later, we'll see examples where that memory is a little more blurry.
Yeah, I've got some examples later that are a bit different.
Okay, cool.
So on this one, we got the function, and we can just
let's run it.
We can just run it.
Right, and people will see it work, and it'll be like, oh my God, that's amazing.
It should just print two strings and quit.
Starting up. Beep, boop, bop, boo. Pause for effect. Is it going back to the internet to get more Python? No? There you go.
Okay.
Oh, that's an AOT demo, so it actually,
oh, yeah.
That's why it was slow. Because that very first time I compiled it from scratch, and it went and it did a whole AOT as well. I forgot about that. Okay? Now, can I change this, though?
Yeah. So if you add another parameter to that function, so do name, that's it, str.
Okay, and then maybe we'll pass in a string.
Name.
So now I'm going to hit save, control.
Name.
This is name?
Yeah.
Okay, I'm going to hit control S. So just save that. And then we'll go over here. And cool things wants, so this has changed.
Yeah.
That's a string.
Because we're using a source generator, it's an incremental change. So if you make changes to the Python function, if you add any parameters, change the return type, anything like that, it'll automatically update the interface.
Another thing that's really nice is I want to call out that he explained here in English invokes the Python function 𝗦𝗲𝘀𝗀𝗀𝗀 and then includes the method signature for that as well. So you've gone in the source generator and generated the XML source helpers, those little XML comments that then get brought out into Visual Studio, which is a nice little, good job.
I actually added it because it was confusing me. It was just a note for myself.
Yeah?
It wasn't a design idea.
Okay.
It's for my own convenience.
That was really for your convenience. Okay.
Yeah.
That wasn't for me? Okay. Okay, so I'm going to add passing in that string now.
Yeah.
Okay. And then we'll go and we'll run it.
It's probably going to AOT it again, isn't it?
It's going to AOT. Oh, no.
Oh, that was quicker
Go
that time.
fast. It's faster that time. Hey, that worked. Ah. Thank you for that smattering of applause. Only took a half an hour.
Okay.
All your hard work for that moment. Cool. That's amazing and super interesting. So we wanted to call out that this py.cs is getting generated, but I never had to look at it or think about it.
Yep.
Right? This is just a hello world, but I want to go and challenge you because I said I don't believe you, and I'm serious about that. So I'm going to add a console.read line. I'm going to go and start without debugging. I'm going to run that thing again. Then I'm going to go into Process Explorer because Mark Russinovich is sometimes in the room trolling us. And you have to use, it's required at Microsoft to use his tools at least once in every demo. And then we're going to go to AOT console app. And then we'll go down here and look for DLLs. And I'm going to look for
Python 3.
Python.
12.
What?
12.
What?
There it is.
Python in memory with Win32, with Microsoft extensions. There's the C runtime. Here's kernel base. This is all the stuff. Now, this is an AOT'd .NET. So if it wasn't AOT'd, we'd see even more stuff in here. But you can see system.collections and there's system.console. So you really are using up, you're living in the same space. There's no python.exe running.
Yeah. So when you run it, it doesn't flash up with a little app in the background. It's running in the same process.
Okay. So you know, you're familiar probably with WSL, right? The Windows Subsystem for Linux. And I like to say that the Windows Subsystem for Linux was created when people would go out and Google with Bing for a solution, and then they'd be scrolling through their system, and then they'd go, oh, this is great. This is exactly what I need. And then you get to the page, and it says, yeah, drop to the command line, and it says $. And it doesn't say C:, whatever. And you just go, oh, I shouldn't be here, right? Just go and grep for that. Oh, right? I feel like that because I will go all over the internet and I'll find something. I'm like, oh my goodness, Anthony Shaw talked about this in his blog. It says, yeah, just go to the command line, go pip install. I'm like, I don't know what that is. How often do I find myself in a situation, sir, where I want to find some external dependency and then I am suffering? How can you help me?
Yeah, so that definitely comes up a bit. And the first demo we showed you was printing some strings on the screen, which you can do in .NET.
Yeah, we do have that ability now.
OK, cool. All right, good.
Yeah, that was in .NET 10.
It's coming soon. It's coming soon.
It's going to be really fast.
So to, I guess, go a little bit further with the demo, we had 3 demos: basic demo, slightly less basic demo, and then the last one is called advanced demo. So,
well, and this one happens to be specifically, there's basic demo, and then there was Scott is confused demo.
Oh, yeah, OK, we renamed it.
Yeah, because I got confused.
So yeah, before we get there, I showed on that last one, we're converting strings backwards and forwards. Like I said, we use different encoding between Python.NET, so we handle that for you. Python has numbers. C# has numbers as well, which is really cool. They are very different. Python integers are actually analogous to .NET's big number, I think it's called. They're infinitely long numbers, whatever you can fit in memory. C# has got ints, longs, and long.
We got like shorts and uints and other kind of other random ones there.
And the long is actually a long.
And these are really aliases for system dot and 32.
Yeah.
There's that as well. So yeah.
So yeah, what we've done is we've worked out, okay, what's the equivalent for each of these Python things? So floats, strings, bytes, things like that. And then when you get into generics, so if it returns a list of something, then we'll return back a read-only list. We do the same thing with dictionaries. So in Python, we love dictionaries. So often functions will take dictionaries, give you back dictionaries. We also love tuples.
Is it tuple or tuple?
I have said tuple or tuple.
Tuple. Is it aluminium?
It is aluminium, yeah.
It is aluminum.
It's not aluminum.
No, it's not. Centrifugal.
Centrifugal.
Centrifugal. So you love your tuples.
We love tuples in Python, and we love dictionaries.
Huh?
And actually discovered a strange thing about .NET. What's the maximum number of items in a tuple, Scott?
I hope unlimited.
17.
No.
Don't ask me how we found that out.
You know the way that you find that out is when you make 18.
Yeah. Also, in Python, if you've got something which is a generator, so if you yield values, we support that as well. So it will basically give you the equivalent back in .NET. And if it's a coroutine, then we give you back a task.
Coroutine.
Coroutine, yeah.
Never heard of that.
Yeah, so for async and await, actually, fun fact, Python's async and await proposal was actually based on the semantics of .NET.
Yes.
In the PEP.
Teaching the third graders, right? Third graders.
Teaching the third graders. Honestly, if you ask a fourth grader what is a coroutine, they'll just spit it out flat.
Oh, yeah. Very believable.
So in Python, something can be awaited, so it's a coroutine, and it will yield values back to you. So,
okay.
The equivalent is task. So if you gave it a Python function, which was an async function, that is a coroutine, essentially, we generate a waitable method in C#.
I'm really impressed that you have a type called bytes, plural.
Yeah.
You have list, not lists, but you have bytes.
When do you ever need a single byte?
Touche.
Yeah.
All right, so I've gone out there and I found some information and I want to see how to add a dependency real quick. Let's find a dependency and then we'll get into our advanced demo.
Yeah. Okay, so in this one, we've gone a little bit more advanced. I'm going to zoom in.
Thank you, sir.
I don't have quite the proficiency that Scott does with that button. I've made a function which, actually, let me make that bigger because this type signature gets a bit wild. So this function is to calculate the k-means inertia, which I don't even know what that means.
Well, we're doing that in 4th grade.
I'm not. That's 5th grade.
Oh, my bad. My
Yeah.
bad. It's maths.
So this one takes a matrix, which is a list of tuples, and the number of clusters, and it gives you back a tuple, which has got two values. It also uses sklearn, which is scikit-learn. So it's slightly more advanced. It also uses NumPy, which is a numerical processing library for Python. It's kind of quite popular. So those are requirements. They're dependencies that we need to load into Python. And because it's running in .NET, they're things we want to be able to import and load at runtime.
Okay, so in .NET, we put this in a CS proj, and we'd run NuGet, and we get those packages. In your world?
We have a text file. That's how advanced we are in Python. So we have a text file called requirements.txt. And yeah, you just list out the requirements in that file. That's what you do in Python. And then on the .NET side, we have a couple of extra things. When you install the requirements, you put them in a virtual environment. So you don't just install them globally. You put them in an environment that's only for that one project. Okay. So we've got an extension method for that. And then you have to install them as well. So we've got an extra extension method for installing them using the package installer, which is called pip. So we support two. One's called UV. It's really popular right now. And the main one's called pip.
Okay, and you got a couple other things for Mac versus where are you getting these things? If you're on a Mac, you get it from here. If you use NuGet, you get it from there. Little herbs and spices that you can decide on how you want your Python to come down on that particular application.
Yeah. So if you need to put in dependencies like scikit-learn, NumPy, anything like that, you can just drop them in, and then you just call the functions. Everything you saw in Scott's demo works the same. The Python code, essentially, you're just importing those libraries and calling them directly.
Okay, cool.
Cool. All right, we'll go to, there's too many buttons.
Yeah, would you want to go back to the slide? There you go, that slide.
Okay. All right.
So we did that.
We've done that one.
I feel less confused now.
Okay.
So I can go and I can see pip stuff and I can bring it down.
Okay, so we talked about strings. Strings, we kind of copy them across, but the big use case here is AIML. A lot of AIML is essentially matrices of floating point numbers. If you lift up the hood of an LLM or an AI model, you'll see a lot of floating point numbers, and basically lots of matrices and lots of matrix calculations. So that is what you get with a lot of AI calculations and with machine learning as well. The way that they think is all in floating point numbers. So copying those backwards and forwards over rest would be horrendous. Even just copying them within the same process would be quite expensive. So what we've done is we have basically the actual storage format of those arrays matches what is in .NET. So a float, a 16-bit float, a 32-bit float, we have those in .NET, don't we? We've got floats.
Yeah.
Cool. So we can do single, double precision floats. And with bytes, for example, bytes are, what do you call bytes in .NET?
Byte.
Byte.
Array.
OK, bytes. We can actually make that memory in Python available to .NET, and we can issue a span of bytes. So a span essentially is a way of accessing memory with a type structure.
Right.
So if you've got bytes in Python, we've got this little trick where we can tell Python, OK, .NET has a reference to that memory, so don't just make it disappear, please.
Right, and span of T was a huge thing that happened in .NET from a performance perspective, and we've slowly been taking pieces of the underlayment without you knowing it. We've been actually changing the engine of the plane while it's in the air, and things just get faster. And this has been happening now for like a half a decade.
Yeah.
So the fact that span of byte exists and allows you to go and say, it's that span over there, and will just be the same, is huge.
Yeah. So
otherwise, you'd be copying an entire array of bytes over.
Yeah, so this is one of the killer features of CSnakes, is that if you've got a large amount of memory, you're doing any AI/ML work, you can effectively just access that memory directly from .NET. So for bytes, it's easy. For a one-dimensional array, it would be a span of T, again. So if it's called a vector, a 1D array. So if it's a 1D array of floats, we just get a span of float back. If it's an n-dimension array, so if it's 2, 3, 4 plus dimensions, which you often get in training cycles, we've got this cool new thing called a tensor span. Have you heard of a tensor span, Scott?
I know that those are two English words put together.
OK, tensor span is a .NET 9 feature. So yeah, you've got to have .NET 9 to use it. Okay. It is basically a way of accessing a n-dimensional piece of memory with a specific type and structure. So if you're working with a training matrix, or you need to share a lot of values backwards and forwards between .NET and Python, you can use a tensor span to do that.
Yeah, and tensors are essential to what's going on when you're working in AI/ML. It's an expression of this algorithmic vectors in space, and to be able to have that with the power of span of T and as a native thing makes .NET 9 kind of really well placed for doing AI work. But then I might go to something like Hugging Face and find that this is something that is not available to me. I might go and say, I want to use that. Mm-hmm. Do I have support for that? Getting that into the .NET world might be challenging.
Yeah, so if you go to Hugging Face, you've got all the models that are available right now. We've got 1.7 million models available. And we've got this kind of trending line. So I just thought, OK, what's trending right now? NVIDIA Parakeet's trending. It is a automatic speech recognition model. It's pretty cool. If you scroll down on that model, we're like, how do we use this from .NET? Pip install. OK, so I can pick pretty much any model at random on Hugging Face, and you will see the same thing. It will say, this is how you pip install a package, and you run it. Like I said earlier, Python and AI go hand in hand. Mm-hmm. So I thought what would be cool is in Hugging Face, we've got this package called transformers. So later on, you'll see not the robot, not the little tiny metal things you're making on TikToks. Mm-hmm. Okay. Yeah.
Glad that you saw that. I'm making like metal transformers on TikTok. It's my new side gig.
So we've got this package called transformers, which is for Hugging Face, and it will fetch the model for you, and then you could interface with it. So this works with all types of models. So what I thought would be cool as a demo is I've put together a wrapper for transformers using CSnakes called Transformers Sharp. And this is, I'd say this is demoware. This isn't production ready. I've basically taken the Python transformers package that's available, and I have written implementations for tokenizers, embeddings, and different types of AI model pipelines. So if you're using text generation, for example.
So these are classes of models that I might want to use.
Yeah.
Because the one that's Parakeet is not a large language model, right? It's a speech model.
Yeah. So when we say AI today, I think everyone tends to think of LLMs. That's one type of model. There are many, many types of models, and there's a lot of innovation going on in the other types. So this is text generation, so basically implemented a package. Now, the cool thing about this package is that the fact that it actually runs Python is almost like an implementation detail. So Transformer Sharp you could use, and you would put in a package from Hugging Face and run that package in process and use the technologies we've been talking about so far. But you're consuming it as .NET, and you could just go and pull this, and you can use it like this. It's pretty straightforward.
And I would never know if I chose not to.
Yeah, you wouldn't know. You wouldn't know that half of Python is actually written in C, unless you really dug into the details. So if we wanted to pull in a model and just run that model and generate some text, you just call it from .NET directly. So that's what we've put together, and ASR actually is a cool thing. So if I wanted to use parakeet, for example, I would just go to the top and copy the name, I think. You just copy the name of the model, okay. And then in the code, you need to, where is it? Here we go. So instead of OpenAI 𝗦𝗲𝗀𝗀𝗶cie, you would just drop in the parakeet model, and it just go and fetch that model and run it for you. Also implemented, we've got MEAI, which is Microsoft Extensions AI, has a speech-to-text client. So this is something I think has been shared a build this week. Mm-hmm. Implemented a bridge between Hugging Face and that. So kind of demonstrate what we can do with CSNX and how powerful it is. Basically made probably most models on Hugging Face available to you. The other ones you'd maybe need to tweak the Python a bit. Sometimes they need extra libraries and stuff like that. But it means we can pull in those things and run them.
So hundreds of thousands, if not 1 million plus models are now available running in .NET happily.
Over 1 million, yeah.
Over 1 million with CSNX.
Yeah. Cool.
But wait, that's not all.
Okay, so to finalize our demo, what I thought I would do is use this library and drop it into an Aspire app. So I've got a backend API service, which does the communication backwards and forwards between .NET and Python. So it handles, okay, what are we going to give to the AI model? How do we get the data, send it backwards and forwards? We've got all those benefits that I talked about earlier with the spans and the high-speed memory sharing. And then we've got a front end, and I'm really good at front end development. So this
excellent. Vibe coding is working.
Yeah. So our program, let's have a look.
Now you're in VS Code, it looks like.
Oh yeah, I use VS Code.
So again, we're non-denominational. He's in VS Code. I'm in VS. Totally cool. Works everywhere.
So I've got an object detection endpoint.
Maybe zoom in just a smidge. I'll just move my face closer.
Okay. This one. Okay, I added an API. And at the top, I've said, okay, use Facebook's Data ResNet, which is actually quite a common model. And let's make that available as an API endpoint. So we just call the detect method on the URL, and it will go back and it will give us some data back. And that is basically gives us back some information about what is detected.
And I'm not seeing any Python yet, right?
No,
it's just a Blazor front end. You were doing a C# in there. Like Python is hidden from me at this point.
It's an implementation detail at this point.
Python is an implementation detail.
So I've run that. I've clicked on that in my front end. I've given it a picture of my dog. And with the magic of AI, it has identified that there is a dog in the picture.
Dog.
So this is like the most low-key AI demo that I could think of.
It even put a square around the dog.
Yeah, it did. So that's a bounding box. And we've just done that in Razor. So I've got like an object detection Razor page. And because it's .NET and because it gives me back a typed structure, I can see, where are the lines, where do they start, where do they finish, and I can just render that in HTML. So that effectively is a Python program running behind the scenes, but we're running it in the .NET process, and I've made it available into Aspire. So another cool thing about that is because we're all running in the same world, we're running in the same program, the same process. In Aspire, if I go and look at, okay, what's happening in the console, then I just look at the API, and I can see anything to do with Python that's been written to standard output. It's moaning about the weights of the model checkpoints. I don't even know what that means. Like any warning messages and stuff like that. Because we're running in the same process, I don't need to introduce some new logging infrastructure or some new way of capturing that. If my backend program throws an exception in Python, then it catches an exception in .NET, and you can see the stack trace. So you're basically bringing the two development ecosystems together, and it makes it a lot easier to develop things like this.
And if you spend any time looking at any of the 𝗲𝗲 talks, you should, because not only do we have something like this with 𝗲snakes, but you could have a .NET process, a Python container that's just running regular Python, running Django or running whatever, and then you can have 𝗲snakes, and they can all talk to each other. So if you wanted to do the whole Python in its own space thing, you could do that. 𝗲𝗲 is just like the natural next step for this, being able to put all that stuff together in one project. And was it hard?
No. It was this entire library, actually, this 𝗦𝗲𝗀𝗀𝗸𝗁𝗁 sharp library is less than 500 lines of code. So taking an ecosystem of 1.7 million models, and with 500 lines of C#, most of that was using statements, I think, but
Oh!
it's like
So now you've got some folks helping you now, right? You said Aaron Powell's helping, 𝗦𝗲𝗀𝗁𝗁𝗁𝗲 is helping. Can other folks get involved?
Yeah, absolutely. So this is an open source project. This is a fantastic nerd sniping project as well, if you now want to get involved and get interested in it. So 𝗲snakes is open source. It's on GitHub. We're running our backlog, our feature program in there as well, any requests for this. We have been looking at a whole bunch of use cases. In terms of our development priorities here, so yes, I've been contributing quite a lot to this, but there's about 10 people quite actively involved in this project.
Oh, wow.
So yeah, a lot of developers. Coincidentally, most of them, their first name starts with A. It's not a requirement. If your name starts with other letters of the alphabet, that's okay.
You will be sorted, though.
Yeah, your PR will be deprioritized based on in alphabetical order.
Yeah.
So yeah, we document everything here, how you can get started.
What's not done? Is this a 1.0? Is this a 0.9? What's broken? If I push this hard, what would go wrong?
What's not working? That's a good question, Scott.
Yeah, thank you.
And a surprise one. We didn't plan for this.
No, I didn't.
Look, I say in terms of our priorities, I'd say that compatibility is the first one. So I don't want to introduce something that we need to be constantly keeping up with Python releases, keeping up with .NET releases, because I want to take time off and go on holiday, and Python moves at 100 miles an hour. There's 500 reasonably active contributors to Python. There's a lot of people working on .NET. Both ecosystems are moving really, really fast. So it's been built in a way that we can maintain compatibility, and I can go on holiday. The other thing is that performance is a massive priority. So we have a lot of benchmarks to basically get the best performance we can between the integrations. Because if performance doesn't matter, you could just use HTTP and REST today, that works. But this basically gives you a different way of developing and a different way of writing code.
Would you put this into production?
Yeah.
He didn't even pause.
Yeah.
It's such a badass thing to do.
Yeah.
He didn't even pause.
Yeah, I say that, but the most successful application I've written is this. I don't know if you've seen this, Scott.
What is this? Oh, did you guys know? Zoom in, man, zoom in. Oh, Control 4. Don't do what. So did you know Anthony wrote VS Code 𝗬𝗀𝗄𝗃? The greatest extension in the history of all extensions. You can add any pet. You can have Clippy. You can have dogs. Throw a ball at the pet.
Oh, with a zoom, hold on. That one, there we go.
Give the pet another friend. I'm a big fan of VS Code 𝗬𝗀𝗃. It's the first thing I install. Second thing is the Beyonce extension for second or third is definitely VS Code 𝗬𝗀𝗃.
Okay.
So now he's got a friend.
Yeah.
That was the most successful app you've ever done.
Yeah, 1.7 active million users. I'm actually not joking either. I've been a software engineer for a while, and yeah, this is my big break, so that's great.
So we would encourage you to go out there and install, in order, VS Code 𝗬𝗀𝗃 and 𝗲snakes. So to get 𝗲snakes working, you just clone it. You've got .NET on your machine. You don't have to install Python. and .NET Run one of the samples, and it will work.
Yeah, so 𝗦𝗍snakes is a NuGet package. You just download it. The instructions on the 𝗦𝗍snakes app as well. How do you unzoom from control?
Oh, you hit Control-4 again.
Okay, all right, thank you.
That's live zoom versus regular zoom.
I'm learning something live. Here we go. So yeah, if you go on the app, on the website, you'll see some information about how to get started. And yeah, we got through the advanced demo. And then, yeah, we can talk about some of the details. So 𝗦𝗍snakes is on that QR code on the left. And the right-hand one is the transformer sharp one. Like I said, that is a small demo. It's 500 lines of code. And it's mostly written so that you can see how you would do this. That one, I would say, probably not shipped to production. Like, we don't have any.
Transformer sharp, you would wait?
Yeah, I've got like a small range of tests for it, but nothing robust. But yeah, 𝗦𝗍snakes is very, very heavily tested. And yeah, we're still looking for feedback on this. So we've been sort of incubating this for the last year and really interested in what .NET developers think of it and what they can do with Python. And yeah.
And then I want to have two short advertisements. One is that .NET Conf 2025 is happening November 11th, where we will launch .NET 10. That will be GA, so be sure to check that out, .NETconf.net. And then I would also encourage you, if you are interested in some exciting third-party conferences happening this year, there's one in Orlando called Dev Intersections. And then there's one in Portugal, if you are of the European persuasion, you want to join us in Lisbon, at AzureDevSummit.com. So be sure to check out both of those. But above all, please check out 𝗦𝗍snakes, because it's an absolute joy, and I think we should give Anthony and his team a big round of applause. All right. We hope you have a great show. We hope you enjoy all of the folks that are hanging out with us here. And you don't have to go home, but you can't stay here.